All right. Second video of the statistical forecasting series. I'm gonna be. This video is gonna be only concerned with dissecting the seasonality characteristics of the time series data. So besides seasonality, there's also the trend and cycle aspect. But in this video, only the seasonality is what we're gonna be focused on for now. Formal definition of seasonal pattern, pattern that repeats itself every year. A little strict on that definition, but we don't have to follow it. Just kind of just more focus on pattern and consistency. All right, deterministic and stochastic. I kind of went over it in the last video, but kind of similar to trend is deterministic. The pattern is determined. Stochastic is kind of the more realistic, less predictable pattern. All right, moving on to what makes the seasonal decomposition a little more unique is the quarterly, monthly, and weekly aspect. So when these seasonal patterns happen every quarter or happen every 4 months, then we'll say the pattern is quarterly. So I can't think of a specific example of something that happens every quarter. I guess weather. So, a lot of times we expect more precipitation during the winter, and so if we use a quarterly type of observation for that, we'll expect higher precipitation during the winter, less precipitation during the summer, maybe kind of in between for fall and spring. All right, sorry about that. And so we have monthly and weekly. So monthly, we can kind of, again, using the winter example, if we have, December and January with the common holidays, then we'll expect, if we're predicting stock prices of products that are commonly bought during the holiday, then we'll expect an increase in January and December for monthly. And weekly is pretty much self-explanatory because I gave the examples of quarterly and monthly, so I think weekly should be easy to figure out what that means. And so the way we can mathematically model this is what we call the seasonal dummy model. And so in this model, we have this time variable, which we're going to use to represent the trend, because the trend is more general. But here we have these dummy variables where we represent each type of season. So if it's monthly, then we'll have 12 months from January to December, and we'll measure each coefficient of the month. So maybe December and January, the consumption spending will be higher, so maybe it will be around 500, arbitrary number, but 500. And so if our spending during like the summer or during fall, it will be probably lower, and so these coefficients will, it can be 200, 300, whatever it is. But the whole point is that we distinguish these monthly observations to measure the coefficient of each month. And the whole point of that is to see which part of the season has higher spikes and or coefficients within the season. The trend is already modeled. All right, this is just another example of how we can expand our seasonality aspect this is a holiday dummy variable, and this is a trading day variable. And so holiday, like I said, maybe during Christmas, Valentine's Day, Halloween, whatever, these spending expenditures will be higher, and that's how we can distinguish it from our non-holidays. Same with trading day variations. Maybe during trading days, our spending will be higher. And obviously, this doesn't have to be spending. It's just whatever we're measuring. Just practical wise, we're usually measuring financial data. So probably one of the more common examples. All right. This isn't particularly related to seasonality, but this is when we're forecasting, types of forecasting related to the mean. So I'm going to go over this pretty quickly. Starting from the standard squared error, the mean squared error, we calculate each of the differences between our fitted and actual y value. We square it and divide it by n. So that's the method we've always been using. The mean absolute deviation doesn't square it. So the MSE will always be, the absolute value of the MSE will always be 2 times higher than the absolute value of the MAD, it will always be an absolute value, but kind of similar. The second one, the mean absolute percentage error, kind of in its name, it will give a percentage, so it's in proportion to the whole y value. And so you can kind of think of this as the correlation versus covariance, where the first and third ones are giving in raw measurements, and the second one's giving in a proportion. So the second one, in a way, is more useful, but we will have instances where the first and third one are more useful sometimes when we can kind of grasp how big or small the raw values of our measurements are. All right, visual example of seasonality. I guess this is it. So this is a relatively quick video, but a visual example of our seasonality model. So let's say these numbers in the x-axis represent months, y is houses built. And so we get a consistent seasonality of earlier months we get a small drop, and then during like the early middle of the months we get a huge spike of houses built and a gradual decline. And so that's the obvious analysis. But often we're also concerned with, why that is. So why are way more houses being built, or increase of houses being built in the earlier months, and pretty noticeable decline in the later months. Well, what do the later months? What can the later months potentially disrupt from the houses being built? Well, that's probably precipitation. There might be other factors, but when rain and snow comes, we don't want workers to be building houses outside. That's not the most ideal. And so we want the houses to be built early of the months, after the rainy months are over with, and we want to finish before the rainy seasons come again. And so that's how we can kind of interpret and second-hand variably. Okay, that's not a real phrase, but I don't want to say overanalyze, but just more critical thinking into the analysis part of the seasonality aspect of this time series plot. All right, this is a quick video. So as you can see, try to make this only about seasonality, but in the next couple videos I'll do forecasting cycles, and then we're also going to be combining that in as well. Trend is pretty straightforward, so I'm not going to be analyzing that, but next video will be cycles.